Comptia Network Plus course. Interoperability. IPX SPX isn't as ubiquitous as TCP/IP, which can even be found running on Coke machines, but it holds its own when it comes to allowing many different platforms to talk. Windows 9X, NT, ME 2000, NetWare, OS/2, and a few versions of Linux out of the box with support for communication. Out of the box. Out of the box with support for communication with other entities via the IPX SPX protocol stack. Before the popularity explosion of the internet in the mid-1990s, the IPX SPX protocol stack was the only protocol stack many companies would run. The only downside to interoperability using IPX SPX is that many versions of Unix and other high-end operating systems like OS 400 don't come with built-in support for the IPX SPX protocol stack, or even with an option for support. Naming. Really, the only items that have names are the network servers. Generally speaking, you can name a network server anything you want as long as you follow these rules. The names must not include any of the illegal characters, including a period, comma, plus sign, an equal sign, and a backslash. Names must be less than 48 characters or 47 characters in older versions of NetWare. Names are not case sensitive. These names are resolved using either binary services or novel directory services. NetBEUI. NetBEUI is a network layer protocol designed to provide support for NetBIOS networks. NetBIOS is a protocol that was developed by IBM and later enhanced by Microsoft and Novell for use with network operating systems like LAN Manager, LAN Server, Windows 9X, Windows NT, and Windows 2000. It is very fast and efficient protocol with low overhead. Because it is small and efficient, it works well on small LANs with between 10 and 200 nodes. The two protocols are often referred together as NetBEUI and NetBIOS. Naming and addressing. There is very little network addressing with NetBEUI NetBIOS. Actually, for NetBEUI, naming and addressing are the same thing. Each station is configured with a unique name called the NetBIOS name that is used for all communications. It's simple and quick. The only item that must be configured on the workstation is the name of the workstation. Is the name for the workstation. Routing. Because NetBEUI and NetBIOS protocol stacks do not have route discovery protocols and was never designed to be routable, it can't be routed. All routers will drop NetBEUI NetBIOS packets. Some routers, however, are smart enough to try and bridge these packets to all segments when it finds out that the packet is NetBEUI. Interoperability. Only a few operating systems run NetBEUI and NetBIOS. The operating systems for IBM and Microsoft are the primary supports of this protocol. Windows 9X, NT 2000, LAN Manager, OS/2 support NetBEUI. These operating systems can therefore communicate using NetBEUI NetBIOS. The Macintosh operating system, however, does not support NetBEUI natively. AppleTalk. When Apple introduced the Macintosh in 1984, the Mac included networking software. This networking software used a protocol known as AppleTalk and a cabling system known as LocalTalk. It is very simple and elegant protocol in that the computer takes care of most of the configuration. You simply plug it in and it works. Because of its simplicity and popularity, and because Mac users wanted a faster version, Apple developed the AppleTalk version 2 with support for Ethernet EtherTalk addressing. Each station on the AppleTalk network uses an address that is 24 bits long. 16 of those bits are given to the network. Each network segment can support 254 nodes. Each network segment can be given either a single 16-bit network number or a range of 16-bit network numbers. If a network is assigned a range of numbers, that network is considered an extended AppleTalk network because it can support more than 254 nodes. The node address is automatically assigned by the computer itself. In addition to network numbers, AppleTalk networks are called zones. Zones allow an administrator to divide a network into logical areas for easier administration and make it easier for a user to find resources. Routing. AppleTalk wasn't originally designed to be routed over a WAN, but with the release of AppleTalk version 2, Apple included routing functionality with the introduction of the Routing Table Maintenance Protocol (RTMP). RTMP is a distance vector routing protocol like RIP for both IP and IPX. Interoperability. The only computer that comes with AppleTalk installed by default is the Macintosh. Most Windows operating systems are able to use the AppleTalk protocol but require that additional software be installed. Naming. AppleTalk uses the name byting protocol (NBE) to associate the name of the computer with its network address. It is broadcast based. Every station broadcasts its name when it comes up on a network. The AppleTalk router on a network will cache these names and respond to the NBE request. When a node requests a name resolution, a local router will answer with information it has obtained from this cache. Summary. In this chapter you learned about the OSI model and had an introduction to a few of the most popular protocols in use today. You also learned about the 7 layers that make up the OSI model, including from top to bottom, the application, presentation, session, transport, network, data link, and physical layers. You also learned what each layer's primary responsibility is. In later sections, you learned about which devices operated each layer of the OSI model. You also learned about some of the major protocols, including TCP/IP, IPX, NetBEUI, NetBIOS, and AppleTalk, and how the different parts work together. For each protocol, you learned which parts of the protocol that handle the concepts of addressing, routing, interoperability, and naming. So I hope you liked this video. If you did, please consider like, sharing, and subscribing. And thank you again.